I am the narrator for Bestiae Primalis. This channel is dedicated to the scientific examination of animal life. We do not simply present compelling imagery of the natural world. Our purpose is to explain the underlying mechanisms that drive animal behavior. We focus on the principles of cause and effect that govern survival and adaptation. Today, our subject is the Arctic wolf, Canis lupus arctos. This formidable predator inhabits one of the planet's most inhospitable environments. It acts as a crucial regulator within its ecosystem, linking the severe Arctic climate, the movements of its prey, the survival of numerous other species. Our investigation is guided by a clear analytical objective. We seek to understand how the Arctic wolf persists, how it acquires energy, and how its existence is intricately woven into the fabric of its stark, frozen world. The Arctic wolf is taxonomically classified as a subspecies of the grey wolf, Canis lupus. Its scientific name is Canis lupus arctos. This classification places it within a lineage of highly successful predators distributed across the northern hemisphere. Its specific range is confined to the high Arctic, Canadian Arctic archipelago, northern coastlines of Greenland, other remote polar islands. This habitat is characterized by extreme environmental conditions. Polar desert tundra, ice fields with very low vegetation. Winters are exceptionally long, dark and cold, with temperatures frequently dropping below -50 degrees Celsius. Summers are short and cool, providing a brief window for reproduction and resource acquisition. The Arctic wolf's existence is a testament to its ability to adapt its behavior and physiology to severe constraints. The physical form of the Arctic wolf is a direct product of evolutionary pressures imposed by its frigid environment. Every aspect of its morphology is a solution to the twin challenges of heat conservation and effective predation in a landscape of snow and ice. Its dense, multi-layered coat is a prime example. Outer guard hairs are long, coarse, hollow. They trap air for insulation and repel moisture. Beneath lies a thick undercoat, the primary barrier against heat loss. In the coldest months, the fur can be several inches thick, allowing rest directly on snow with minimal energy cost. Shorter legs, a shorter muzzle, and smaller rounded ears reduce surface area and heat loss, aligning with Allen's rule and Bergmann's rule. The paws employ countercurrent heat exchange, warm arteries adjacent to cold veins. Heat transfers to venous blood, cooling arterial flow to just above freezing at the paw. This prevents tissue damage while reducing conductive heat loss. Large fur-fringed paws act like snowshoes, distributing weight to avoid sinking. Stiff hairs between pads insulate and improve grip. Pads are thick and tough. Together, micro to macro scale traits form a sophisticated cold-adapted suite. The behavior of the Arctic wolf is governed by a strict and unforgiving calculus of energy. Every action must be weighed in energetic cost versus potential caloric reward. Hunting, resting. Energy optimization is the central theme of its behavioral ecology. In the high Arctic, food is scarce and cold forces high metabolic output. Conserving energy is paramount. Behaviors are tuned to maximize net energy gain. Activity concentrates when hunting chances are highest. Activity is minimized during the harshest weather. Polar summer, 24-hour daylight, wolves hunt whenever prey moves. Polar winter, continuous darkness, long rest periods to conserve energy. This plasticity lets them exploit rare hunting opportunities. They do not waste energy on fruitless activity. The hunting strategies of the Arctic wolf are a masterclass in cooperative problem-solving and energetic efficiency. When hunting muskoxen, the wolves employ a highly coordinated and patient approach. A typical muskox hunt begins with observation and testing. They approach and move around the herd, probing for weakness. Their goal is a vulnerable individual, young, old, ill, or isolated. This phase is low energy, avoiding a premature confrontation. Once a target is selected, the attack phase begins. Muskoxen form defensive circles or lines, horns outward. To break formation, some wolves feign attacks to draw attention. Others rush from another angle to separate the target. This tactic requires coordination and communication. Chases are short and intense. long pursuits are too costly. Surprise, teamwork, and a swift, decisive attack bring down prey. For an Arctic hare, a lone wolf uses stealth and a sudden burst of speed. For caribou, packs steer prey into difficult terrain to neutralize speed. They may rotate pursuers in relay fashion to manage fatigue. Social organization. The pack as a cohesive unit. The fundamental unit of Arctic wolf society is the pack, typically a nuclear family. At its core is a dominant breeding pair, sometimes called the alpha pair. Modern ethology prefers breeding pair to reflect cooperation. Usually the only pair to reproduce, the rest are offspring from previous litters. These subordinate wolves play vital roles in survival. This family structure reduces social conflict. Members are closely related. They share a vested interest in the pack's success and pup survival. Cooperation is the cornerstone. Division of labor is flexible but essential. Some adults hunt for days, others guard the den and care for pups. Hunters return to regurgitate meat, feeding pups and den sitters. Cooperative provisioning nourishes all, boosting pup survival. The breeding pair guides movements and initiates hunts. Younger wolves learn by participation. Communication, a language of subtlety and distance. Communication among Arctic wolves is a complex, multi-layered system, essential for cohesion and territorial defense. The most iconic form is howling. In open tundra, sound travels for many kilometers, reuniting separated members and advertising territory. Body language gives immediate nuance. Tail and ear position, head carriage, overall posture signals status and intent. Ritualized postures reduce fighting and save energy. Facial expressions and eye contact are part of the vocabulary. Scent marking, urine, feces, gland secretions defines trails, kill sites, and range boundaries. In cold, dry air, scent persists, allowing passive information sharing across distance. During hunts, posture shifts and eye contact coordinate flanks and feints. A soft bark or whimper can flag hidden prey. A howl can rally the pack for a long-distance chase. Together, vocal, postural, and chemical signals fuse the pack into a single coordinated unit. The Arctic wolf functions as a keystone predator, exerting a disproportionately large effect on its ecosystem. Its primary role is regulation of herbivore populations, muskoxen and peary caribou. Predation is selective, often removing old, sick, young, or otherwise weakened individuals. This has a sanitizing effect, potentially reducing disease and maintaining genetic vigor. Beyond kills, wolves create a landscape of fear. Vigilance and avoidance reshape herbivore distribution and behavior. Altered grazing patterns allow recovery in pressured patches, shifting plant communities and soil nutrient cycling. Wolf kills provision scavengers, Arctic fox, ermine, wolverine, ravens, glaucous gulls, especially in lean winters. Wolves channel energy from large herbivores to smaller consumers, increasing food web complexity and resilience. Remove wolves and herbivores may overshoot, overgrazing followed by crashes, scavenger guilds decline, biodiversity wanes. Maintaining predator-prey relationships is critical to tundra stability. A kick from a muskox can be fatal. Risk minimization is integral. Wolves disengage when cost outweighs reward. After success, they gorge to replenish and cache remains, buffering future shortages. Caching extends the kill's value through time, another mechanism of energetic efficiency and ecosystem provisioning. The Arctic wolf as a barometer of change. In summary, the Arctic wolf, Canis lupus arctos, stands as a premier example of evolutionary adaptation to an extreme environment. Its physical form, insulating white fur and a heat-conserving body plan, is a testament to natural selection. Its behavior is a finely tuned calculus of energetic efficiency, each action weighed against the unforgiving Arctic. A complex social structure centered on a cooperative family pack raises young and hunts formidable prey. Sophisticated communication binds the pack into an effective predatory unit. These traits form an integrated suite of solutions to polar life. Today, the Arctic is changing rapidly. Melting sea ice, thawing, permafrost-altered weather patterns. Such shifts threaten ecological balance and, by extension, the Arctic wolf. Changes in snow cover and prey distributions force territory and behavior shifts. As a top predator sensitive to lower-level disruptions, its population trends are a barometer of Arctic health. For Bestiae Primalis, the Arctic wolf is a case study in resilience and adaptation. Protecting this predator and its habitat preserves a vital thread of Earth's biological heritage and the scientific lessons it carries.